All right, ladies and gentlemen, welcome back to the drive-thru for another wonderful edition of Math Class, sponsored by the Deli. Hungry? Stop by the Deli. I don't know what we have for us today in the Deli. I'm excited for a new opening day. You know, we get new stuff every Monday, so I'm not sure what to tell you about my sandwich today. Okay, this is 9-1. That's not the page I want to be on. Here we go. 9-1, okay? Honestly, I legitimately don't need to make a video for this. Not only did you learn all of it last year, but we've already been reviewing it as classroom warm-ups for the entire year. Not that we've been simplifying radicals for the entire year, but parts of this, as you'll see from this very brief lecture we're about to do, we've been doing as classroom warm-ups. So, if you've been doing those, that's not only good for you because you're keeping your algebra tools sharp, but now this lesson is going to feel like a breeze. All right, so the first thing we're going to do is simplify expressions with radicals in them. So when we see radical 48, you ask yourself, what's the biggest number that can be divided into 48 evenly? Okay? That is a perfect square. So your perfect squares are what? 4, 9, 16, 25, 36. Come on, faster, 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 faster. $225. Okay. So if you know all those, good. If you know all of those up to 100, well, you better, or else you're not in the right class. Okay. Here we go. So what's the biggest number in that list that goes into 48? 16. Many of you would have picked 4, which could have led to some mistakes. You could have picked 4. It just would take longer and involve some possible mistakes. So if I just write this out the long way, not that I expect you to write it out like this, is that right? And so the answer is? Got it? What's radical 18? It is indeed 3 radical 2. It's radical 9 times radical 2, and radical 9 is radical 3. Okay? What's radical 32? It is 16 times 2. Okay, and radical 75? I think it's 5 radical 3, right? I think we had that backwards. 5 radical 3, it's 25 times 3. Okay, now, what's 3x plus 2x? Sorry, what's 3x plus 4x? 7x. So what's 3 radical 2 plus 4 radical 2? You're darn right it is. And can we combine those two? We cannot. That's like 7x plus 5y. Okay? Hi, Jamin. Shout out to Jamin from the Deli. Throwback. All right. Now, this one is kind of annoying, but don't worry about it. I don't know that you've done this one before. It's called rationalizing the denominator. There's some rule that some guy who's way older than me invented, and it said that you're not allowed to have radicals on the bottom of a denominator, or the bottom of a fraction. So what number are we allowed to multiply by in math that never changes the value of a function? Okay, we're going to multiply this by 1. But we're going to multiply it by a fancy form of 1. And that fancy form of 1 is radical 3 over radical 3. Okay, what do you get on the top? And on the bottom? And that is reduced. Right, because that's so much more simple. Sorry, I didn't make the rules. I'm just charged with enforcing them. Got it? Hi, graph paper. All right. So this should look familiar. What are we going to do to solve these? We're going to try to factor, okay? But we can't factor until they're in standard form. So we got to move the 16 over. And now it's a riddle. We're looking for two numbers that multiply to be 16 and add to be negative 10. So the only way things can multiply to be positive but add to be negative is if they are both what? And what is it? And could we have written it as negative 2, negative 8? Sure we could have. Okay, so this means that either x minus 8 equals 0, whoa, or x minus 2 equals 0, just reminding you guys what the heck you're doing. Because the last thing I want you to do is just do algebra without understanding what you're doing. So that, what does that mean? X equals what? Got it? Alright, over to this one. It's already in standard form. Can you think of two numbers that multiply to be negative 10 and add to be 7? Oh, shoot. Yeah, I'm sorry. Let me change this one. Because I don't want to factor it. How about that? Oh, would it have not have worked? Oh, correct. Oh, this might be imaginary. Hold on, I probably shouldn't have picked this one. Multiply to be negative 11 and add to be positive 7. I bet this is going to work. I just think one of them is going to be a fraction. Like, I think this might be like, I don't know. Let's see if it works. Okay? So, is this factorable? It is not. So if it's not factorable, what do we go to? What is it? X equals what? Minus b plus or minus big square root of b squared minus 4ac all over 2a. Okay, so what's our b? Our b is 7, so we write minus 7 plus or minus big square root of 49 minus 4 times 1 times negative 11. Good. Okay, this is indeed rational, or it's, what's the opposite of imaginary? I don't know. Real. Real. This is a real answer, sorry. All over 2. So it's minus 7 plus or minus the square root of, what's 44 plus 49? 95? Is that what you get under there? All over 2. So since we're in the simplifying radicals section, we are not going to write, did I do something wrong?
I think it's
93, it is. Since we are in the simplifying radicals section, we are not going to write our answer as a decimal, although I'm all for decimals, okay? So, do any of these numbers from this list go into 93? 9 doesn't. I don't think they do, right? I forgot my plus or minus. That's my answer. That's my answer. That's the best I can do. Okay? Can I get a quick boom?